but we're going to talk a little bit about Neo4j, we're going to talk a little bit about building APIs, and we're going to talk a little bit about cloud. So my name is Jennifer Reif. Both of our contact information is down there, because of course all of our best questions happen after the conference, and then we don't know how to reach out to somebody. So if you have questions afterward, feel free to contact either one of us. We're more than happy to answer that digitally, however you're most comfortable doing so.
And I'm Mark Heckler. I work for Microsoft, so we tag team on this and have a great time with it. So again, our coordinates are down at the bottom. If you think of something 10 minutes after you walk out, that happens to me all the time too. Don't feel bad, just ping us. But we are going to be around the rest of the day too. So I mean, if you can find us, great. If not, shoot us preferably a Twitter DM, right? Because I mean, email, but Twitter is faster. So ping us there.
Okay, so background on me, I'm a developer and advocate at Neo4j, have been for just over 4 years now, and I like learning. I like learning technology. Hopefully most of us are in that same boat, or we all wouldn't be here, right? But then I like sharing what I've learned, and usually that's through a variety of facets, things like blogging, or speaking at conferences, or meetups, or virtual events. Any of that is all fair game. And then there's other things I like to do outside of work too, but most of those just boil down to the fact that I'm kind of a geek. So that's me in a nutshell.
Again, my name is Mark Heckler. I've co-authored and contributed to several books. I've also written my own book solo, which I swore I would never do after co-authoring other books. But you break promises to yourself. So what else are you going to do during COVID, right? So wrote a book. It's down there. If you wanted to check out a free sample, you can go to the link at the bottom. I am an architect and developer by trade, developer advocate at Microsoft for Java and JVM languages, Java champion, Java 1 rockstar, Kotlin developer expert, and a licensed pilot, because it's always good to have a different perspective on things, which is kind of fun. So.
All right, so let's talk a little bit about what makes a good graph. I'm sure you guys are probably maybe getting tired of this by the time you hit day 2 of the conference. But we'll talk a little bit about kind of what we were looking at when we started looking at data sets. So one of the first things is that you're looking for various types of entity types that you might want to query across, right? So lots of different types of entities, queries that span multiple different types of entities. And you want to analyze the connections between those. Those connections are super important. You also might pick graphs when you have something like consistently changing business models and business needs. So if things need to adapt and move along as the business changes, or the industry is a very fast-moving industry, you might want to choose something like graph for that flexibility. Another one is looking at lots of layers of impacts or dependencies, again, kind of diving into those nested depth structures. That's another good example for graph. So when we were looking at a data set, how in the world would we go about choosing something? Well, again, relationship context is going to be important. The relationships have value, right? So we wanted to find something in that avenue. And we wanted to look for multiple types of entities that were all going to be connected to one another. One data set we came across was this Kaggle Netflix data set, and this information is all linked at the end too, so if you want access to that, you can find it. It did have one little limitation, and that was that the country codes were 2-letter identifiers, so it didn't have the full country name. And I don't know about you, but I don't know all the country names in the entire world by the first 2 or the 2-letter identifier. So I went out and found a Wikipedia list of country names compared to their 2-letter identifiers, and was able to add that to the set as well. So again, now we're looking at multiple data sets that we're kind of adding and aggregating together into a single graph.
Fully ISO compliant, by the way.
So this is what we came out with our data model. We have productions in the middle, so this is kind of like our movies or shows. We could also add things like Broadway plays or operas or any type of production we wanted to put there. But we're just dealing with kind of shows and movies at this point for Netflix. And then we have genres that they're categorized in case we wanted to search or based on that. We have the countries that they were produced in, which again, we're expanding with the full country name from the Wikipedia data set. We've got IMDb and TMDb information that could help us connect different movies together. And then we have the characters and the people that were involved in those movies. So what persons played characters, what was their role in the movie, whether they acted or directed or so on. Okay, so let's talk a little bit about the way I imported the data and kind of the key things that I looked for and key things I had to work on. Data import always takes a little bit longer than you hope or expect it would, right? So first off, we were dealing with CSV files, and this is a very common data format to find out there, some sort of flat file, either JSON or separated value of some sort, right? And so I could use the load CSV command inside Cypher in order to pull that data in, and then used some APOC that would help me kind of grab the dynamic labels there in the second row, and that would create our productions. And then I created nested queries there to create the genres and the relationships, and then the countries and the relationships there in the next nested query. So that loaded our productions in right there. And then I wanted to load people. Now we had over 60,000 rows on that person CSV file. And so in order to kind of help avoid running out of memory or causing lots of problems, I ended up batching these using that :auto at the very beginning. And then the second to last line has in transactions of 20,000 rows. So I was able to batch those into 20,000, and that kept me from running out of memory on my database. And then I loaded those people, and then I used APOC to create custom labels again based on values in the CSV. So top to bottom, we had 2 CSV files coming from that Kaggle Netflix data. We had another CSV file that had the Wikipedia country names. I used Cypher statements in order to load the information in with a little bit of APOC magic sprinkled on top. I started in very small pieces, so I constructed each individual Cypher query and then was able to kind of add on and create kind of these somewhat larger queries to process larger bundles together. I also batched some of that stuff, as you saw. And these are not all the import statements, just kind of a sampling of them. The full list is available on my GitHub. But then I used multiple statements to conserve memory. So I loaded production separately, then I loaded people, I loaded countries separately, et cetera. And you can script this, so you could write update scripts or just load scripts in general to populate the whole data set. And you can also schedule things like that using something available in APOC as well. So you have lots of different options available to you, whether you want to load it all at once or create a repeatable script, or you want to do consistent updates that are scheduled. Okay, let's dive in and live code.
Okay, so you please pardon us, we are moving rather quickly, and we did scope things down rather tightly because they tell us we only have 4 hours to get this done. That's right? 4 hours? 40 minutes, it's pretty much the same, right? But we basically took a large data set and a large domain and tried to skinny it down to where it's something we can deliver meaningfully and cover all the concepts we want to cover. So that's the goal. If you have any questions, comments, or feedback afterward, if you feel like we maybe gave something a little bit of a short, slighted it to some degree, we probably feel the same way, and we'll happily talk about it, expand on that as we go after the fact. So. In order to build an API, we like to leverage Java and Spring. Any Spring developers here? Very few. That's kind of surprising. Pardon? Retired. Well, maybe we can draw you back out. So yeah. So Spring Data Neo4j is a really awesome library. It's a starter that works with Spring Boot applications. Spring Boot takes, in many languages, you have a lot of boilerplate that you have to do to interact with data stores and build APIs. There's a lot of repetitive stuff you have to do. And after you do that 10 or 20 or 100 times, you kind of become numb to it. You don't realize how repetitive it is because it's just the way you have to do it, right? It's just the way it's done. Spring Boot simplifies and streamlines that so you can focus on the business value, getting things delivered for your customers, for end users. So we're pretty partial to that. Neo4j and Spring work very well together, as you'll see. We're going to start, and we have this small portfolio of microservices we've developed that we have already pre-deployed to the cloud, but we're going to show you one segment of that, one slice of that. So we're going to create a person service. We already have a production service out there running, which allows us to query the various productions that are in Netflix at this point in time. And now we're going to create a person service that allows us to track people who are involved with those various productions, movies or shows, people who directed them, people who starred in them, played in them in some role. So I'm going to use the Spring Initializer. It's kind of a jumping off point for creating the project. It doesn't generate code per se, just the main application class and main method, but it generates your project based on the dependencies you specify, and then we can take it from there. So I'm going to use Maven for my build system and Java for the language, but you have options even there. I'm going to use the current version of Spring Boot. We're going to just change this to thehecklers.com because that's my domain, and it doesn't work if I don't put that. I don't know why. Kidding. But anyway. Tough crowd. Okay, so If you came for the jokes, that's the best they're going to get, because I'm just dad jokes all the way, start to finish. But okay, so we're going to create a person service. We'll call this, cleverly enough, person service. And we're going to use jar packaging, which for Spring Boot, self-contained executable jars lets you run anywhere there's a JVM. That's nice. Current long-term supported version of Java, Java 17. But you can go on up to 18, which is the 6-month release, or you can go back to the previous LTS releases. We're going to stay with the latest, greatest LTS release, because why not? That's where we live, right? And we're going to choose some dependencies to bring in. So things like Spring Web to build, as it says, build web, including RESTful applications using Spring MVC. Let me zoom in on that. So that's kind of nice. That's your imperative. Whoops, let's see. And I want to bring in reactive web. I don't think we're going to have time for that, but I'm going to bring it in anyway, just in case. Hope springs eternal, right? And then actuator for our production-ready features, so we can get like the health checks and things like that. And then also, of course, because we are at Graph Connect, we're going to bring in Spring Data Neo4j so that we can work with Neo4j rather comfortably and easily. So I'm going to generate the project now. There we go. Okay. Sometimes it gets it's a little sluggish, so we're going to drop that on the desktop. I'm going to open that up, just unzip the project. And once again, it's not placing things where I want them. And we'll open that in our favorite IDE, NetBeans. Kidding. Okay, this is not a predominantly Java crowd, I can tell. But anyway, that's fine. So this is fine. Even if you're not a Java person, you're going to recognize a lot of the same constructs. And in fact, you may actually become a Java convert when you see this, because it does tend to streamline your life and make it a lot easier for you to get done what you need to get done. So what I like to do is start off with the build file and just double check that everything's in there as we would expect it to be. We have our actuator dependency, our Spring Data Neo4j dependency, our starter web, and our starter web flux. So that's our imperative and our reactive API builders, our libraries, if you will. I'm going to open up our application properties, which is where we put our sensible defaults. We want to tell it where to start, what port to start on, because we already have something running on the default port of 8080. And port conflicts are generally a bad thing, right? So I'm going to just put that in there. We don't really have to add a Spring application name, since this thing we're going to be running locally, this particular instance of the person service. But if we were going to deploy it to the cloud and use a configuration service, which we do, I'll show you that later, we would indicate its name here, so like person service, so we can get the properties that apply to person service. And that applies whether we have one instance of it, or 100 or 1,000. It will go out and grab those unique properties that apply to this kind of service. But let's go ahead and get rolling with the code, right? That's where we live, right? Everybody here is a developer or has their hands in code to some extent, designer, yeah. So this is where we live, right? This is where we see the rubber hit the road. So I'm going to start off, and we decided we're going to use Java 17 records, because why not? We fully support them here. And we're going to create just our domain to start off with. So we have a person, right? And then we have the character that person may play, right? Character. And then we also want to keep track of, obviously, the production. So what are the properties? In Java 17 records, if you're not familiar with them, you can define them like this, and it handles a lot of, they're basically a data container, right, at the highest level. So we're going to define a few properties, and I should actually say that these are all nodes. All these have value as nodes in Neo4j, right? So let's get started. Our production, we have an ID here. And this will be, we'll call this our production ID, right? Mm-hmm. And then we have, let's see, so we have our title, because the production should have a title, Stranger Things, etc. And then we have a description of that particular show. And then we should have something like, if I can spell, we should have something indicating when it was released. So the release year for a particular show, movie, series, what have you. And then we also should have a rating, so TVMA or PG-13 or R or whatever the case may be. And then finally, we should have the runtime, so we know how long this show may run. So we can decide, we really don't have time to watch a 3-hour and 20-minute documentary tonight. We'll watch it some other time. Okay, so in terms of character, we have to keep track of an ID, of course, and this is a generated value. Yeah, oh, well, generated value, I got a little ahead of myself. And this, we don't really have a value for the character itself, so we're going to just use an internally generated Neo ID, right? And then we also want to keep track of the name that the character is, what that person is playing in that particular production. And then, of course, for person, we have an ID, and this will be our person ID, cleverly enough. And then...
You need the data type there.
Oh,
That's
yes.
why it's...
Wow, I'm just
It's a long...
rolling right ahead here. This is what happens when you narrate as you go. And then, of course, here we have, this is a string. And then we have a string for the name, the actual person's name. And then we have some relationships here. And in this case, we're going to have the relationship called played. And this will be a list of characters, right? Because this is the character that this person played in a particular production. There we go. And this, we'll just call this, again, cleverly enough characters. And then we'll have, oh, you know what? I'm just going to do this and get rid of this. And we'll just bring this up to directs because we're going to be listing the productions that this person directs, and we'll say directed for our relationship. Okay, that should cover the general domain, right? That wasn't terribly painful. We have a fairly meaningful and fairly rich domain here. Even though we've scoped it back, it's pretty complete. Now we just need to create a couple of things. One will be our API, so we're going to create our a REST controller, which will provide a mechanism by which we can supply an API. So we'll call this our person controller. And I may just defer that to you because, you know, share the wealth, right? And then I'm going to create the interface here for our person repository. Now, if you've crafted database access for applications before, you realize that can get kind of involved and kind of painful. Spring Boot has a thing called auto configuration. And we are going to define an interface. We're going to extend the Neo4j repository interface, which is defined in Spring Data Neo4j. We're going to be persisting items or objects of type person with an ID type of string, right? And this, simply by extending an interface defined in Spring Data Neo4j and having Neo4j's driver on the class path, Spring Boot's autoconfig says, I bet you want to talk to Neo4j. I mean, this isn't tough, right? Some folks call this magic, but it's actually just technology, right? It's just opinions. This makes a lot of sense. So we have everything we need. And just by doing that, we have certain built-in functions. So we can do a find one, we can do a find all, and these are pre-built methods that Spring Boot or Spring Data handles for you, right? Spring Data Neo4j. We can also delete one, we can delete all, we can delete by a particular ID. And that's great to get you started, and that gives you a certain amount of functionality for you working on your behalf. However, we're going to take things a little bit more specific, right? So we're going to have some abilities to do some particular queries that we want to be able to do. So we want to return an iterable of person, right? And we'll say, how about we do a find by name? Come on, by name, right? And you notice this is offering us things. And this is, again, this is Spring Boot's auto configuration, Spring Data, providing the ability to use field names, member variable names, so we can do things like query by convention, so find by name containing. And we're going to say that we want to provide a certain amount of text, and that should be able to provide that method on our behalf, which is really cool, right? We don't have to write that, and it's consistently applied. We also want to provide the ability to retrieve, maybe not all, because we have 60, 70,000 different people that we're associated with just this little data set that we're dealing with today. So we might want to do something like a find sum. And we may want to limit that by a particular quantity. Maybe not, but maybe we will. So that's kind of handy if we want to do that. And then we also want to return things like an iterable of person, where we can do a find characters played by, and provide that person's ID, right? And then maybe we want to do the same thing for find productions directed by. And I'm going a little off script here in terms of the capabilities that Spring Data will provide for you out of the box, but we're going to flesh this out because one of the other nice things that Spring Data allows you to do is to supply queries in the query, the driver-specific DSL that you have. So in this case, we're using Neo4j. So what do you think we're going to use for the query? Anyone? Oh yes, okay, good. I don't have a spare t-shirt to give you, and if I take this off and throw it to you, everybody will run out, so I'm sorry. But yeah, we're going to use Cypher because that's super powerful, and we can do that to good effect. So okay. I'll tag off on our database expert here now.
So we want to look for persons, and we're passing in an ID, so I can look for person ID. is the value that we're passing in. And then we need a relationship of played, because remember we're looking at characters and we have people who played characters. And then we need to look on the other side of that for the character itself. And then we're going to return the person. We're going to collect the relationships based on that person. So, and then put into a list the the characters that that person played as well. And then we're basically going to copy that, and we're going to come on down here. And that didn't work quite as nicely as what I would have liked, but okay, basically we're just going to change this to directed, and we're looking at, instead of characters, we're looking at productions, and I'm just going to call this production. And we're going to return the person, we're going to collect the relationships, and we're going to collect the productions. Okay, so that looks good. And then we need a query for this one down here. Now this one's a little bit different because we are just returning anything that's connected to a person at this point. So we can do a match, we're looking for person, and any type of person at this point. So we're not looking for a particular ID. We want any relationship from that person, and we're going to look for any other node connected on the other side of it. And then we want to return P, collect the relationships, collect the other nodes, and then we want to limit by a particular quantity that we're going to pass in, potentially. Okay, so that looks pretty good now on our queries. Those are our custom queries, and we can dive right into our controller now. And we don't need to define a custom query for this one because, as we said, Spring will kind of derive the method based on the parameters and the structure of the method name that we've given it. So this one kind of does itself for us, which is nice. So first thing we're going to do is we're going to inject our repository. And we're just going to call this repo.
Spring Boot will create a bean for your repository automatically as a proxy to deal with your database. So if you're used to having to deal with this much boilerplate to even do a simple query on your database or get a count of the number of rows or anything like that, this takes that all off your plate to where you can immediately start interacting with the database. It closes automatically too, so it's really, really a sweet deal.
Yep, and the first thing we're going to start with, I've created a constructor for to inject our repository as well. And the first thing we want to do is just kind of create a backup method for us here that basically just tells us, hey, you can actually reach your application. The service is actually up. We've had a few instances when we've demoed that things go terribly awry. And
no, wait, that never happens. Things always go perfectly in live coding.
We don't write buggy code.
Right. If you don't bug your code, you never have to debug your code. So that's how we try to live. But
well, it gets tricky when you have database credentials and database involvement and all sorts of things. So if you can reduce that a little bit and just check it with a status check, basically, it kind of helps. Okay, so now we want to find. Let's start with our find sum example here. So we're going to return an interval of person, and we're just going to call this find people. We want to potentially pass a quantity here, right? So we're going to send in a request parameter. We're going to say it's going to not be required. So if somebody doesn't specify a quantity, then we'll kind of set a default here in just a second. And this is going to be a long value. And then we want to return repo.findSum. And then we can specify, okay, if our quantity is null, we can use a default of, let's say, 100. And then otherwise, we will just use the quantity they've specified.
So earlier, what I did, or what we did really, because she did the hard part with the queries, is create the interactions with the data store we particularly wanted to do to develop an API. And that's what we're doing now, is developing that outward-facing API. You had a question?
Yes, I wonder, so if you could go down to the query.
Sure.
And there we return an interval of person.
Yes.
But what does the collect do in the query? Like
So.
return the person and collect.
Yeah, so the collect is basically, in Neo4j, when you have unique patterns, you're going to get a separate result for each unique pattern. So if that person played in multiple things, you'll get basically duplicates of person based on the different productions they're connected to. And so what this does is it's making person object unique and then collecting everything they're connected to into lists.
But where does it end up? Like,
Well,
does it end up in the person object?
It returns, well, if...
Yeah. So when we tied the relationship here, we're pulling characters, which are connected entities, and we're pulling productions, which are connected entities, into this person object.
So it's kind of like automatically adding characters and everything.
Yeah.
Yeah, and the fact that she didn't specify a particular relationship there, just said R, means it gets all relationships. So in that particular interaction, it will return everything associated with that person, regardless of whether they directed in, acted in, or both.
Yeah.
Or
we'll see an
directed,
example
I
of
guess.
where that's
Yeah.
not the case actually here in a
Okay,
second.
yeah.
But okay.
Yes?
So on the first one, find by name containing.
Yes.
Yes.
How do you know at this point that Spring Boot can do that one, but you need to provide a query for the other ones, right? With
good question.
That's an excellent question. When I started typing, it will basically extrapolate from your member variables. So the fact that you have a name there, it says, hey, look, I can find by name because I know what that is. So it gives you certain defaults by convention. If it doesn't prompt you with those, then it's basically out of its reach. And that's where you can go crazy because you can do anything you want as long as you have the query DSL interface.
Yeah. So that's likely to work with pretty standard data things like name equals.
Yes,
like
exactly.
Ages.
Starts with, ends with, contains. Yeah.
But where you get
covers,
like a lot of criteria involved or a lot of kind of complex things going on in your queries, that's where it might just be easier to go with custom query.
Which is an extremely, as you can probably tell, it's an extremely powerful tool because when you're building out APIs, you follow a lot of the same patterns over and over and over again for, I don't know, let's say 80% of the things you do. But that 20%, that's super important to be able to give the exact response in the particular way you want it. And that's where the query DSL just opens up everything else. You can get 80% very quickly and easily, and that 20%, it doesn't keep it off limits. It just says, okay, you know exactly what you want, you supply it, and we'll run it. And that works, not to take away from Neo4j, but it works for any particular query DSL for any particular database driver.
Yeah. Okay. So now we can dive in specifying our characters, and so now we can implement this method. So again, we're looking at iterables of persons coming back, and let's just call this find characters, and we're passing in the ID, and so we need a request param here, but this we do want to be required because we want to have some ID being specified, otherwise we retrieve everything, and then we need our string ID. And then return repo dot characters played by, and then pass in our ID. Okay, and last but not least, we have our directed, or directs. Yeah, that's how I did it last time. Okay, and person, and let's do find directed, and request param again, so same general idea here, ID, and we're going to do a return of repo dot find productions directed by and pass in that ID. Okay, so I think if I haven't forgotten anything, we should be in good shape.
You can't, yeah, I was gonna say, we have to run it from outside at the command prompt because we have a few credentials that we need to use to access AuraDB.
And is it inside this folder?
No, it is not. Actually, it's out in desktop. Oh, sure. Okay.
Sometimes it's just easier. He knows his folder structure.
Yeah, we've tag teamed back and forth in various different machines. So Maven, Spring, Boot, and we'll just run it.
Okay. And then we can open up a new tab whenever that looks
Sufficiently initialized.
Yeah, starting. Okay, there's a lovely little spring. Okay, so we're going to use HTTP and 8082. Yes, so this is our health check. So just making sure the application is up and running. Okay, cool. So we see our message right there. The service is up.
It's a good start. We can just stop here, right? Just in case.
We wish. Okay, so we have now, this is our sample. We're going to find some, but remember I didn't specify quantity. So therefore it's going to return the default of 100. So I could scroll all the way through. We're not going to count all 100. But let's go ahead and, oops, there we go. I'm learning new shortcuts. So
since we're using Z shell, we have to put everything in a string so it doesn't choke on us when we start putting different.
Let's say a quantity of 3. Okay, so we get one person back here, two person here, and three person here. And that is it. So we got 3. So that is working correctly. Let's shift and do
Find by name containing.
Find by name. That's it. Find by name. And we're going to pass it a name equal to, let's try Ron Howard. He usually is involved in a lot of stuff. Yeah. Oh no. What did I do?
Hey, this didn't happen. This is not the endpoint you're looking for.
Oh, this was text, wasn't it?
Oh, no.
Don't you
Here.
need to encode the space?
No, actually, because we got it in
quotes.
All right.
So let's see what we got messed up here. So get mapping, sorry.
Directs.
You didn't code it.
Oh, I didn't. There's the problem. No wonder.
Computers, they're so literal.
Okay. So find by name. All right, let's do an iterable. A person. We're going to do the find by name. Come on. And we're going to send a request param. Yes, required. Yeah. So string name. And then return repo dot find by name containing and pass in name. Okay, now we should be in better shape.
Now let's go start it in the
Let's go try
tab,
this. There we go. Again, keystrokes. All right, restart that. And then pop over to the next tab and try rerunning this. Oop, that didn't work. There it goes. Bad request.
come on. Text.
Yeah, text. My bad.
Yeah,
Typos.
so literal.
There we
looks a
go.
little
Okay,
happier,
success. Okay, so now we're getting back our person, and we see we're getting everything here. Now again, I specified that query. It'll retrieve everything, everything back there. Okay, actually this query I did not specify, but Spring did it for me, so.
Yeah.
All right, so now we have Ron Howard right here. We know he's got some connections here, so let's go ahead and look for the characters that he's played. And we know his ID. So we're gonna specify 1324, yep. Okay, so we get his characters back. Notice that we did not get the directs because I did not specify that relationship in the query. So it's going to just specifically pull characters. But again, that value is specified on our domain, so that's why it still shows up in the listing. But we have his 2 characters. Now we can basically do the same thing, but for directs. So we can find the things that he directs and pull that instead. And now we see our characters are empty, but now we have the things that he directed. Now, of course, he probably directed a few more things than this, but our data set must be somewhat limited.
That's what's on Netflix right now, so for him.
Okay.
So
I
we're
think,
going to carry on? Okay.
Yeah, I think we're ready to turn it back over to, oh no, you were going to do Azure.
Yeah, let me just kind of, because again, this is about leveraging the tools to work for you. So let me go ahead and, before I do that, yeah, I probably should show that, shouldn't I? So we did deploy this to the cloud, as you might expect. Let me blow that up.
And this was all running locally, but we have renditions of this deployed.
You can do this in several different ways, but I'm very partial to Azure Spring Apps. I work for Microsoft, so I'm fond of it. But so that's the commercial plug. But seriously though, Azure Spring Apps is our goal is to make that the ultimate target objective, the ultimate destination for your Spring Boot applications. So I created a Neo4j service running out here. And that's based on Kubernetes. So who here loves to work with YAML and loves the complexity that Kubernetes brings to their deployments, their systems of systems? Yeah, you love the power, let's be honest. You love the power it gives you, but you don't love having to do like 50 million things to deploy a single application. That gets kind of old fast. I'm very fond of saying as developers, we embrace a lot of complexity because we have to get the job done, but then we're saddled with it every time we release something from there on out forever. And that's not so fun, right? So we want to be able to focus on delivering real business value to our users. And that's one of the things that Azure Spring Apps does. It builds on Kubernetes. It orchestrates everything. You have Spring Cloud components in there where everything talks really well together. But you basically point an application at it or a service and you tell it, scale this for me on these criteria and tell me all about it. And you can still interact, you can still engage at any level, but you don't have to by and large, which is pretty sweet. So a very quick tour of that. We have these apps deployed out there. Again, the person service we already have out there deployed. We also have the production service. I also have an API gateway because typically you don't expose all of your different services to the outside world. You've funneled them through an API gateway, so you control security and access and rate limiting and things like that, so it protects your system of systems. We have an admin service to give us a little more information. We don't have a lot of time. We're really tight on time. So I'm just going to give you the kind of like I'm going to cherry pick the 2 or 3 things that I love the most about it. You can define alerts, set metrics where you can see what's going on, but I'm going to just dive specifically into the application insights, because this is really, as a developer, where I think the rubber hits the road. I go in here into application insights, and I'm just going to pull up the map, because this tells you what's going on in your system of systems. Come on, you can do it. Don't embarrass me here.
Refresh or something.
Yeah, I love it when things go just perfectly. All right, well, while that's coming up, I'm just going to go to another window. And there's another one thing that I want to show you. It's like 2 things. I skinnied it down to just show 2 things, and it's just still giving me grief. See if that came, oh, it did come up. All right, see, I navigated away from it, so it was less self-conscious.
It's an application graph.
That's right. So it gives you a nice application graph. It tells you your production service, your API gateway, the interactions here with the person service to production service. If I want to, well, let's see, I'll just go in here. Let's go to our apps. So if I go to I'm not sure this will happen quickly enough to really make it fun to show, but I'm just going to grab this value, and I can pull it up in the browser window, of course, but yeah, we live in the command line, so there we'll get our status report. And then if I really want to go, what a director of, isn't it?
Yeah, yep.
And then ID equals 1324. We'll do that for Ronnie again. And this is actually causing an interaction between our different services. Instead of keeping everything queried within the data store, we're going to actually have our services interact. And then if there is time, we'll come back and we'll see that this updates to where we see the interactions between them.
Because we have both services deployed, and we can either run that query locally, or we could actually hit the other service and run that query and ping the other service, basically.
Yeah, so it's not coming up fast enough for me, because it's doing every few seconds refresh. So if I go to view details, we'll just go into the live metrics on this.
Yeah, and we'll jump back to slides.
There we go. Yeah, it's a little sluggish. I'm wondering if our internet is.
Could be.
So you get a lot of valuable insights into how things are operating. You can set up scaling rules, so it actually handles scaling for you, scale out, scale in. You can nest them, so if you know that load is less on weekends, but it's bigger on like holiday weekends, you can set these things up, and it works for you. Again, the whole idea is you have a lot of great tools at your disposal. Use them. Let them work for you, so you can focus on, again, the things that you want and need to get done for your customers and your end users. So with that, let's go back over and finish up the slides. I've already talked a little bit about the platforming and the automation in terms of the configuration and deployment. Script everything, make it idempotent, so you can run it 1 time or 100 times and it all comes out with the same results. It gives you a lot of power and flexibility, whether you're deploying to multiple environments like dev, test, prod, or different target environments, different regions, and it makes it very consistent and easily reproducible. You want monitoring and management to be handled by and large for you and managed by exception versus having to do the care and feeding of pets all the time.
So we're going to get actionable insights, as we've seen from the graph with our data, our system of systems working and interacting with our microservices, sending data back and forth, and then at the platform level, being able to see and monitor those microservices as well as the platform itself to get alerts or metrics and things on how everything is going. So resources, the person service that we coded today is available on GitHub. The dataset, if you want to load it for yourself, that is available on the second link. AuraDB, if you want to create a free instance, we also have larger instances that are pay as you go, but the free instance works really well for demo projects and testing things out. That's really what I love to use the most. And then the Azure Spring Apps.
Which is not free, but there are multiple tiers, and if you can use a smaller tier, it makes perfect sense. You can do a lot of things that actually work for you, again, to minimize your cost structure. And it obviously scales all the way up to the massive planetary scale stuff, which costs a lot, but if you need it for your applications, makes a lot of sense to employ. So use what works best for you, but you have great options at your disposal, again, that can do a lot of the heavy lifting for you and let you focus on the things you need and want to get done. With that, we're done.
Yep, thank you all.
Thanks so much.